Hello everyone. This is the first mock paper that we are going to discuss. So this mock paper is made for your JEE Main January attempt. I have linked the PDF in the description. You can check it out and give it a try before seeing this discussion. So let's begin with our session. So this is the first question that we are going to discuss. The question says the sum of the series 8 over 5 plus 16 over 65 plus 24 over 325 plus 32 over 1025 plus so on up to 20 terms is, and four options are given. So let us discuss this question first. This question is taken from the chapter Sequence and Series. It covers the concept of telescopic series. So the idea of the telescopic series comes from the fact that here, if we write the general term of this series, it comes out as 8r, as you can see, 8 times 1, then 8 times 2, then 8 times 3, and 8 times 4, and so on. And in the denominator, there are terms like 5, 65, 325, 1025, and terms like this. We can write this as 4 times 1 to the power 4 plus 1, 4 times 2 to the power 4 plus 1, 4 times 3 to the power 4 plus 1, then 4 times 4 to the power 4 plus 1, and so on. So the general term will be like this. This is our TR. R is a natural number. R varies from 1 to 20, as there are 20 terms in this series. So we have to find the summation of this series up to 20 terms. So this will be summation r equal to 1 to 20, then 8r divided by 4r to the power 4 plus 1. Now the concept is to express this numerator in terms of the difference between two terms in the denominator. We have to express the numerator as the difference of one or more terms in the denominator. That is, if we factorize this denominator, it will give us something that we can subtract. So how to solve this summation? Here in the denominator, we are seeing this interesting expression. This is an as important expression that you should remember always, because this type of expressions are very special. 4r to the power 4 plus 1, we can factorize it easily by completing the square. 2r square whole square plus 2 times 2r square plus 1 minus, and we have to subtract this 4r square as we have added it. So 4r square here. This can be written as 2r square plus 1 whole square minus, and this term can be written as 2r whole square. So we can factorize this as, let us write the factor. This will be summation 8r divided by 2r square plus 2r plus 1, then 2r square minus 2r plus 1, where r is running from 1 to 20. Now we have to evaluate this summation and express this as the difference of these two factors. So how do we do this? So we observe that 2r square plus 2r plus 1 minus 2r plus 1 plus 2r square, if we subtract them, we will get 4r. So this is nothing but 2 times 4r. So we will get the expression in the numerator easily. So let us proceed. So here we take the 2 out and then sigma, then 4r, or maybe we can write directly 4r as 2r square plus 2r plus 1, then minus 2r square minus 2r plus 1, and then these two terms in the denominator. So we can write this as summation 1 over 2r square minus 2r plus 1 minus 1 over 2r square plus 2r plus 1. Now see, this relation is valid for r equal to 1 to 20, and this is a telescopic series. So this is the general term. So we put the values one by one of r. So we will get, let us solve this part first. This is, let's call it as s. So this will be 1 over, if we put r equal to 1, this becomes 1 minus 1 over 5, and then plus, if we put r equal to 2 in this whole part, so it will become 1 by 5 minus 1 by 13, and then so on up to, if we put r equal to 20, it will become 1 over 2 into 400, so 800, minus 2 into 20, so 40 plus 1 minus this term. So these terms will get cancelled by 1, and we will be left with s is equal to 1 minus 1 over 841, that is 840 divided by 841. So our final answer will be the value of 2s, that is equal to 2 into 840, so 1680 divided by 841. This is our answer. So in this case, our correct option will be option B. I hope you understood this question. So this is the second question that we are going to discuss. Here it says that alpha equal to integral 0 to 1 e to the power some function of x and then some function of x again, and then integral of this whole function from 0 to 1. Then the least integer greater than or equal to log of 1 plus alpha. So log is base e, and 4 options are given. So how to solve this? If we observe this expression here, this is somewhat familiar, as there is a term containing tan inverse x, and here in the denominator there is a term containing 1 plus x squared. We know that the derivative of tan inverse x is equal to 1 by 1 plus x squared. So somehow, if we can express this term as derivative of this term, then we can easily integrate this whole function, as that will be of the form e to the power fx times f dash of f, then dx, and integral. So this integral we can easily evaluate. So let us proceed with this term first. We can write this 12 plus 9x square divided by 1 plus x square as 9 plus 9x square divided by 1 plus x square, and then the remaining 3 as this. This can be written as x will be cancelled because x square plus 1 is not 0. So this will be 9 plus 3 over 1 plus x square. this is nothing but the derivative of this function with respect to x. So we can write the given integral as integral 0 to 1 e to the power fx times f dash of x into dx, where fx is 9x plus 3 tan inverse x. So this integral can be easily evaluated as e to the power fx from 0 to 1. This will be e to the power f of 1. So f of 1 is nothing but 9 plus 3 times tan inverse 1, so pi by 4. And f of 0 will be 0 because x equal to 0 and tan inverse x equal to 0. Then it will be e to the power 9 plus 3 pi by 4 minus e to the power 0, so basically 1. From here we can deduce that 1 plus alpha is e to the power 9 plus 3 pi by 4. So log of 1 plus alpha with respect to the base e will be 9 plus 3 pi by 4. We know that the value of pi by 4 is approximately 0.8. So 3 times 0.8 will be 2.4 and plus 9. So this will be approximately 11.4. But the question asks for the least integer greater than or equal to log of 1 plus alpha. So the least integer greater than or equal to this number will be 12. Here option C will be our correct option. I hope you all understood this question. This is the third question of this question paper. The question says the cardinality of the set S equal to x such that x lies between 0 to 2 and closed interval, and modulus of this equal to modulus of this. Then we are asked to find the cardinality of this set. You have to take care of these specific terms that are used to denote the number of elements of set. So how to proceed in this question? As we know, mod a equal to mod of b, that means a equal to b or a equal to minus b. That's it. We have to apply this concept only. So now here x minus x to the power 5 is equal to x to the power 5 minus x to the power 6. That is the case 1. And the other case is x minus x to the power 5 is equal to x to the power 6 minus x to the power 5. This is the second case. Now if we simplify the first one, we get x to the power 6 minus 2 times x to the power 5 plus x is 0. And here if we simplify the second term, we get this get cancelled and x is equal to x to the power 6, which basically leads to the fact x equal to 0 or x equal to 1. That means if we consider only the second condition, we get two solutions for x and both of them lie in the given interval. So till now we got two solutions. So let us focus on this part. Now the second part, if we factorize it, we get x times x to the power 5 minus 2 times x to the power 4 plus 1 is 0. If we consider x is not 0, because we considered that case in this first condition, So if we don't consider x equal to 0, then x to the power 5 minus 2 x to the power 4 plus 1 must be 0. Now we cannot directly solve this equation because this is some higher level power that we don't have any formula for calculating the roots. So we need to take help of the calculus, that is the increasing decreasing function or maxima minima or something like that. We need to take help of the differential calculus. So let us proceed with this in the next page. So here let us call that function of x as fx. It was x to the power 5 minus 2 times x to the power 4 plus 1. Now we need to check the behavior of this function in this interval. I remove x equal to 0 because that case is already considered. So if we differentiate this function with respect to x, we get 5x to the power 4 minus 8x cube. That means x cube common and then 5x minus 8. Here, if we use the wavy curve method, that is the critical point of this derivative must be plotted. Here it is x equal to 0 and x equal to 8 over 5. And as the leading coefficient is positive, so here plus, minus, plus and so on alternatively. So here the function increases like this and then decreases like this and then increases like this. Here it is f of x. Now here at x equal to 0, f dash x 0. So let us calculate f of x at x equal to 0, that is f of 0 will be 1. And after x equal to 0, the function decreases monotonously. Now at x equal to 1, there is a point where f of x equal to 0. So we can directly say that at x equal to 8 by 5, f of x is less than 0, because at x equal to 1, f of x equal to 0, and after x equal to 1 and till x equal to 8 by 5, the function is monotonously decreasing. So at x equal to 8 by 5, the functional value is negative, and after 8 by 5, it is monotonously increasing. So now we can clearly determine if this is the line or the x-axis, if we say, then at x equal to 1, the function crosses x-axis. That means there is a root of this function. And after x equal to 8 by 5, when the function is monotonically increasing, then there must be another one root of fx something here. So that means this is one of the other roots of fx. So we can say in this interval open 0 to close 2, there must be a root of f of x in open 8 over 5 to closed 2. That means the total number of roots that the given function or the given equation have is total 2 plus 1, that is 3. These two are x equal to 0, x equal to 1, and this is x equal to say alpha, where alpha lies in this interval. So the correct option for this question will be option B. I hope you all understood this question. The next question says that let Snx is a sum of a series containing some logarithmic terms up to n terms, and S30x is this, then the locus of the point x comma y is asked. So the question says that it will be a conic section whose eccentricity is to be determined. Now here, if we carefully observe the given expression, we can easily detect the property of logarithm to be used here. Let us recall the property of log. Log of b raised to the power m with respect to base a is m log b with respect to base a, and log of b with respect to the base a to the power m is equal to 1 upon m log b with respect to base a. This is the property that we have to apply in this question. So let us create some space. Here, if we rewrite the series as Sn x is equal to, we apply logarithmic properties for all the terms, then we get 2 log x base y plus 3 log x base y plus 6 log x base y plus so on up to term n. So nth term. This implies Sn of x equal to log x base y times 2 plus 3 plus 6 plus 11 plus 18 plus up to n terms. So we have to find the summation of this series first. Let us denote this as S. So we have to calculate S. Now for S, we will apply the method of difference. That is, we write S as it is, and we denote the nth term of this series as T of n. Then we rewrite this series again, but with shifting the terms by one term. So we write 2 below 3, then 3 below 6, then 6 below 11, and 11 below 18, and then so on, and Tn minus 1 below Tn, and then Tn. So if we subtract these two, we will get in the left hand side equal to 0, then 2 plus 3 minus 2, so 1 plus 3 plus this will be 5 and this will be 7 and so on up to. So now see, here inside this bracket will be something, and then here it will be minus Tn. Now inside this bracket there are total n minus 1 terms. So this is an AP which is like this, 1 plus 3 plus 5 plus 7 plus so on. Now we know that summation of n odd natural number is n square. So we apply that formula directly here. Here it is the summation of n minus 1 odd integers starting from 1. So this will be 2 plus, then this will be n minus 1 whole square. So we can write Tn as 2 plus n minus 1 whole square. This is the nth term of this S. Let us proceed in the next page. Now we have Tn as 2 plus n minus 1 whole square. If we want S, then we have to summation this Tn from n equal to 1 to n equal to n. So we will get summation 2 plus summation n minus 1 whole square, n equal to 1 to n, n equal to 1 to n. The first term will be 2n, and then the second term will be 0 square plus 1 square plus so on up to n minus 1 square. So that would be, if we apply the result, summation of r square from r equal to 0 to n is equal to r into r plus 1 into 2r plus 1 divided by 6. We apply here, we replace r by n minus 1, so n into n minus 1, then 2n minus 1, then 6. This is the s. So that means Sn of x is equal to 12n plus n into n minus 1 times 2n minus 1 whole divided by 6 times log x base y. Now if we put n equal to 30, it gives us s30x equal to, if we put n equal to 30, there is a little bit of calculation here. So 12 into 30 will be 360 plus 30 times 29 times 59 whole divided by 6 into log x base y is equal to 17,230. Now you can calculate this one. This is some calculation. This comes out to be 8615. So if we divide 17,230 by this, we get log of x base y is equal to 2. That means x equal to y square. Now notice the domain here. So y is strictly greater than 1. That means this equation is a part of a parabola. That means eccentricity of this parabola is 1. This will be our answer, which means option D will be the correct option. I hope you all understood this question. This is the fifth question. It is the question of trigonometry. We are asked to find the value of this summation. So here let us write this in our familiar form. So this will be 2 to the power 0. So 1 times tan pi by 256. Now as this pi over 256 is repeating again and again, so let us denote this term as alpha. So our expression will become summation 2 to the power r tan 2 to the power r alpha. And here if we put r equal to 0 to 6, we will get tan of 2 to the power 0 is 1. So tan of alpha plus 2 tan 2 alpha plus 2 square tan 2 square alpha plus 2 cube tan 2 cube alpha plus so on up to, if we put r equal to 6, 2 to the power 6 tan 2 to the power 6 times alpha. Now here we are to find the summation. Now I want to point out an interesting and important property of this cot and tan functions, that is the cotangent and tangent. So there is a cool property that you can remember, and it is quite important from the point of view of JEE. That is cot of theta minus tan of theta is equal to 2 cot 2 theta. This is the property that will be used in this question. Now our given series is like this. Now if we add and subtract a cot alpha here, we will get the same series. Now if we club these two, that is, we take the minus common and then cot alpha minus tan of alpha, that will be 2 cot 2 alpha with a negative sign. Now this whole series becomes cot alpha from here, then minus 2 cot 2 alpha, so minus we will take common, then 2 cot 2 alpha minus 2 tan 2 alpha plus so on the rest of the series. Now here we can take these two common, we can again apply the relation here, that is it will become 2 cot 2 square alpha, and because of this 2 outside it will be 2 square, so this will be cot alpha minus 2 square cot of 2 square alpha, and then again there is a term containing 2 square tan 2 square alpha with a plus sign. So we can say from this pattern that all these terms will get cancelled and we will be left at last with this term minus 2 to the power 6 cot of 2 to the power 6 alpha plus 2 to the power 6 tan of 2 to the power 6 alpha. So if we apply the same property again, we will get cot of alpha minus 2 to the power 7 cot of 2 to the power 7 times alpha. Now alpha we can write as pi over 256. So this will be the summation of that series. So we can replace this alpha also as cot of pi by 256. Now see here, it will give us 2 here in the denominator. So cot pi by 2 is 0. So this term, whole term, will be 0. So the sum of the given series will be cot of pi over 256 only. This is our answer. So option A will be our correct option. I hope you all understood this question. The next question, this says for x greater than 0, the value of this integral is, and 4 options are given. Fine. So if we substitute tan inverse x equal to theta, then tan theta equal to x. So the integral becomes e to the power theta divided by 1 plus x square. So 1 plus tan square means sec square theta, and then inside this bracket sec inverse root of 1 plus tan square theta. So sec inverse of sec theta, that means theta, because in indefinite integrals we don't consider about the limits, so we will assume that sec inverse of sec x is equal to x. So this will be theta square, and then it would be cos inverse 1 minus tan square over 1 plus tan square, that is cos of 2 theta. So this will be cos inverse cos of 2 theta. That means it would be 2 theta. And here dx will be sec square theta d theta. Sec square theta d theta. So here this sec square theta d theta and sec square theta gets cancelled, and we are left with e to the power theta times theta square plus 2 theta. Now this becomes e to the power theta times theta square d theta plus 2 times integral theta times e to the power theta d theta. That means if we apply integration by parts here, assuming it as first and this as second, we will get first function as it is. So theta square times the integral of second function, that is e to the power theta, then minus derivative of first, that means 2 theta. So 2 I kept outside, and then integral of second function, that is e to the power theta d theta plus this term. Now see, this term and this term will cancel each other. So we are left with theta square e to the power theta plus integration constant. Now here theta we replace with tan inverse x to get our final answer. If we replace theta by tan inverse x, we will get e to the power tan inverse x times tan inverse x whole square plus constant. This is the integral. Now be careful. Here options contains terms like this. Some of you may choose this option as correct option in your exam pressure, so thinking that you have done some calculation mistake here and there will be a factor of half coming here, and you will like take this option as correct option, and then you will be rewarded with a -1. So be careful in this. Okay, now this tan inverse x we can also write as sec inverse root of 1 plus x square and whole square of that. So this is basically the same. So option C will be our correct option. This is a good question because some of us may do all those steps correctly and then end up choosing an incorrect option. So be careful in this type of questions. I hope you understood this question. This is the 7th question of this mock paper. Let P1 be a parabola with vertex at 1,8 and focus at 3, -1, and P2 be the mirror image of the parabola P1 with respect to this line. If the focus of P2 is at m, n and directrix of P2 is 7x plus 6y is equal to P, then m plus n plus P is equal to, and 4 options are given. Okay, so here P1 be a parabola with vertex at this and focus at this. So here let us draw a rough diagram of this parabola. The parabola is somewhat like this. The axis of parabola is not x-axis or y-axis, it is a straight line. So if we draw a line here and take the mirror image of this parabola with respect to this line, the mirror image will look like this. So here this is parabola P2 and this is P1. So the vertex of P2 will be the mirror image of vertex of P1 with respect to this line L. Let us call it L, and L is this. So the focus of parabola P2 will be the mirror image of this focus of parabola P1 with respect to this line L. This is the concept. So if this is S and V is the vertex of parabola P1 and S is the focus of the parabola P1, then the mirror image of them will be V dash and S dash, and V dash and S dash will be the vertex and focus of the parabola P2. So we need to apply the concept of mirror image of a point with respect to a line. The formula of mirror image of a point alpha comma beta with respect to a line ax plus by plus c equal to 0. If we take the mirror image of this point with respect to this line, then let us assume that the mirror image will be x comma y. Then x comma y can be determined by this relation. This is the formula. So when we want to calculate the mirror image of this vertex of P1, that is 1 comma a, with respect to the line 3x minus y plus 10 equal to 0, we need to use this formula. So we will write x minus 1 divided by 3 equal to y minus 8 divided by minus 3 equal to minus 2 times 3 into 1. So 3 minus 8 plus 10 divided by 9 plus 1. So 10. So here we can get x equal to minus 2 and y equal to 9. This is the coordinates of V dash. This is the vertex of the parabola P2. Now let us calculate the focus of the parabola P2. So focus of parabola P1 is at 3 comma minus 1. So we apply the formula here. Sorry, this would be minus 1 and this will be minus 2 times. We satisfy this point in the equation of the line. It becomes 9 plus 1 plus 10. So 20 divided by 10. From here we get x is equal to minus 9 and y is equal to 3. So minus 9 comma 3 is the focus of the parabola P2. So we can compare, this is m, this is n. So we calculated m as minus 9 and n as 3. So we have to calculate p in the next step. So let's proceed on the next page. Now here the vertex of the parabola P2 is at minus 2 comma 9 and focus of parabola P2 is at minus 9 comma 3. So the slope of this line can be represented as tan of theta, that is 6 over 7. Let us plot this v dash and h dash in the coordinate axis. So this is y, this is x. So v dash is minus 2 comma 9, so here, and h dash is minus 9 comma 3, so here. So we know that the parabola will be like this and the directrix of the parabola will be here, such that this distance is a and this distance is also a. So here a is the distance between the vertex and the focus, that is 7 square plus 6 square and a root. So this will be root over 85. Now here, if we use the parametric form of a line, that is the parametric equation of a line, we can say that the point where the directrix cuts the axis of the parabola P2 is, let's say, this point as P. So P can be calculated as V dash, the x coordinate of V dash, that is -2, and as the x coordinate is increasing for P, so we use the plus sign, and the distance traveled in the direction of this line V dash S dash is A. So A is root 85 times the cos of theta. Now here tan of theta is known to us as 6 over 7. So we can easily calculate cos theta from here, that will be 7 by root over 85. So that means that the x coordinate of P will be 5. Similarly, we can determine the y coordinate of P, that is the y coordinate of the vertex, that is 9, and we are using a plus sign here because the y coordinate is increasing for going to P from V dash. So plus the distance traveled in the direction of line, that is root over 85 times sine theta. So sine theta we can determine 6 over root over 85. This comes out to be 15. So we calculated this P point as 5, 15. So now the slope of directrix will be minus 7 by 6. So we can write the equation of directrix. So directrix will be y minus y1 is 15, then slope times x minus x1. x1 is 5. We can write the equation as 6y minus 90 is equal to minus 7x plus 35. So this comes out to be 7x plus 6y equal to 125. So in the question it was mentioned that 7x plus 6y is equal to P is the equation of the directrix. So here P will be this value 125. So P is equal to 125. So M plus N plus P, if we sum all of them, then the answer comes out to be 119. So option D will be the correct option. I hope you understood this question. The next question is from the topic matrices, and especially the topic of adjoint matrices. Here A is given to us and B is the adjoint of A matrix. Then we are asked to find the determinant of adjoint of B. So here we know that determinant of adjoint of B will be simply, as B is a 3 by 3 matrix, so this would be determinant of B 3 minus 1, so determinant of B square. So for calculating this value, we need to find determinant of b first. Let us calculate this. Now, as b is adjoint of a, so we know that adjoint of some matrix is the transpose of the cofactor matrix of that matrix. So this is cofactor matrix of A, that is denoted by AC, and then we take the transpose to get B, that is adjoint of A. So if we take transpose of B again, the right side equals cofactor matrix of A. So here cofactor matrix of A will be B transpose. So we write the matrix here. It will be 2 minus 5 D minus 8 minus 2 7 C 3 minus 5. So now we can determine cofactor matrix of A from the A matrix given to us. So we can determine the unknowns C and D by this relation. So see here, C is the cofactor of this element in A. So the cofactor of this 3 in A will be, so here the sign scheme is plus minus plus, so plus times plus 1 times 3 minus 2, so 1. So that means C is equal to 1. And for this unknown D, this D is the cofactor of this element. So here also the sign scheme is plus minus plus, so here the cofactor of 2 will be plus 1 times 4 minus 3, so also 1. So D is also 1. So the B transpose that is known to us now is 2 minus 8 1 minus 5 minus 2 3, then 1 7 minus 5. Now if we take determinant both sides, determinant of B will be same as determinant of B transpose, that will be equal to determinant of this. If we calculate this determinant, it comes out to be 121. That means it comes out to be 11 square. So determinant B is 11 square. So that means answer should be 11 square and whole square of that. So 11 to the power 4. So option D is our correct answer. I hope you understood this question. The next question says that if the function f of x is this and this is increasing in open 0 to pi by 2, then the range of a is asked. So here fx is this, so we directly differentiate this function to get its derivative. This will be 2 times secant square x plus 2a plus 1 tan x plus a minus 2. So f dash x will be, if we write sec square x as 1 plus tan square x, we will get 2 plus 2 tan square x plus 2a plus 1 times tan x plus a minus 2. So here 2 and minus 2 will get cancelled and we will be left with 2 tan square x plus 2a plus 1 times tan of x plus a. Now this whole expression can be written as 2 tan x as common, then tan x plus a plus tan x plus a. So we factorize this expression as 1 plus 2 tan x times tan x plus a. And as f is increasing in 0 to pi by 2, so f dash x should be greater than equal to 0. That means 1 plus 2 tan x into tan x minus plus a should be greater than equal to 0. Tan x belongs to open 0 to infinity because x belongs to open 0 to pi by 2. So tan x is positive in this interval, so this whole term is positive. So that means if we divide both sides by this term, the inequality sign will remain unaffected. That means tan x plus a should be greater than equal to 0, or equivalently tan x should be greater than equal to minus a. So a should be greater than equal to minus tan x. Now the maximum value of minus tan x will be 0. As tan x belongs to 0 to infinity, minus tan x should belong to minus infinity to 0. That means a should be greater than equal to the maximum value of minus tan x. So a should be greater than equal to 0. This is the range of a. That means option D will be the correct option. I hope you all understood this question. Question number 10 says that if the shortest distance between the lines this and this is 13 over root over 29, then a value of t can be this. We have to select a possible value of t from these options. Now carefully observe these lines. These are two parallel lines because the vectors along this line is b1, which is, let us write this in this notation. So 2, 3 and 4, and b2 of this second line is 4, 6, 8. So this can be written as 2 times this, so 2b1. So that means these two vectors are parallel. That means the lines are parallel in 3 dimension. So we know the direct formula for the shortest distance, that is the perpendicular distance between these two lines in 3D, is calculated as a2 minus a1 cross b divided by modulus of b, and we also take the modulus of the whole expression because we want to get a positive value out of it. And the b vector is the vector along both of the lines. So here b can be taken as this. So this is b vector. So here a2 and a1 are 2 points on these lines, or the position vectors of 2 points on this line L2 and L1. Let us call this L1 and this is L2. So A1, we can take the points t, 4, 3. So in vector notation they will be equal to t, 4, 3. And A2, the coordinates of a point on the second line, the vector representing that point will be 2, 4, 7. That means if we calculate the numerator, it becomes determinant I, j, k, and then a2 minus a1, so t minus 2, 4 minus 4 is 0, 3 minus 7 is minus 4, cross b. So b is this vector, so 2, 3, 4. This divided by the modulus of b. Now the modulus of b is root over 29. this is equal to plus minus 13 by root 29. We took the plus minus because the value of this whole thing can be either 13 by root 29 or minus 13 by root 29. So from here, let us proceed on the next page. We got I cap, j cap, k cap, then t minus 2, 0, minus 4, 2. So 2, 3, 4, and it is equal to plus minus 13. This is the magnitude of this vector. So if we square both sides, then magnitude of this vector, if we calculate, it comes out to be 12 I cap minus 4t j cap plus 3t minus 6 k cap. This vector, if we square the magnitude of this vector, that will be equal to whole square of plus minus 13, that is equal to 169. So that means if we calculate the square of the magnitude of this vector, it will be 144 plus 16t square plus 9t square minus 36t plus 36. That will be equal to 169. That means 25t square minus 36t plus 11 will be equal to 0. We can say that t equal to 1 is a root of this equation, because then 25 plus 11 will be 36 and 36 minus 36 is equal to 0. So t can be taken as 1. So in this case, the correct option will be option D. I hope you understood this question.